Hello everybody and welcome to your video notes on Learning Target 6.1 at the basic level. Just as a reminder, the learning target is I can represent energy qualitatively, which again means no math. I can represent energy qualitatively without energy entering or leaving the system. So really we're talking about a closed system. Okay? In this video, I'm going to do two examples of a qualitative problem that's a closed system. So here we go with number one. And what I would suggest doing is pausing the video and writing down, drawing a beautiful picture of what we got going on here, and then having your drawing an LOL diagram in your notes. So go ahead and pause it, and then once you're caught up, go ahead and hit play. All right, so first thing that we have to figure out is what is in our system. So remember that your system is represented by the O in the LOL diagram. And so if you read through the problem, it says a spring launches a roller coaster from a rest on a frictionless track, so that's going to be important. And then assume the system contains the cart, the earth, the track, and the spring. Really the only thing that's important here is the cart and the spring. But we can write down all that stuff in the O of our LOL diagram. So we got cart, earth, track, and the cart. Okay, so that's everything that's in our system. And then down below is where we'd show energy transfer going in or out, but we're not going to have that because this is the basic level. Next thing you have to do is set where your reference point is. So I'm going to say that the reference point is always going to be the lowest part of your system. So in this case, that's right here. So we're going to say this is our reference point. And this is how we determine if there's gravitational potential energy. So at point A, we've got all this in our system. So since the spring is being compressed, that's going to tell us that we have elastic energy. That's really nice. Still not great. There we go. So I'm going to come over here and give myself 4 bars in the elastic account. And we could do 3 or we could do 2. It doesn't really matter. But I like 4. I like starting off with 4. Then in the end, at position B, the spring is going to go to where it wants to go after it pushes the cart. And in the end, we end up with some height above our reference point. So that's going to tell us that we've got gravitational energy. Let's put a star there. And the car's moving. So we can see that with the little whooshies coming off of it. So that's going to tell us that we've got energy in the kinetic account. So I've also got to worry about that. Now, it doesn't really matter what we would do here. We could do some in the kinetic, some in gravitational. We just have to have a total of 4 bars in the end. So if we got 2 things and we need 4 bars, why not 2 and 2? That seems to work well for me in my head. But again, it wouldn't matter if you had 1 in the kinetic and 3 in gravitational. But you have to have some in kinetic, some in gravitational to a total of 4 based off of what we had in part A. And then down here below, I like to have a qualitative equation. We don't necessarily need that, but the way that would look is we'd have EL, that's part A, equals EK plus EG. So however much energy is in the elastic account, that has to equal the amount of energy in the kinetic and gravitational account together. And then if we want to do some elementary math to help us out with that, we would end up with, we got 4 bars in the elastic account. That's why this is here. And then over here, we've got 2 in the kinetic and 2 in gravitational. And look at that. Our math works out. 4 equals 2 plus 2. Hey, look at that. How exciting. So there we go. Next problem is this one. I think that I copied the wrong one. So we're going to say with no friction. So go ahead and, if you haven't noticed, these are some of the problems from your blue packet, but it wouldn't be a bad idea for you to do this on your own. So you have a car here. The velocity is greater than 0, so it's moving. You might want to, you could show your sushis there. YA equals 0, that's just saying that we're starting at a reference point. And then in the end, velocity equals 0, so it's not moving. And then saying YB is greater than 0 is just saying that your position on the y-axis is above the ground. So go ahead and pause the video, draw your LOL diagram, maybe sketch this drawing right here, and then see if you can do this one on your own. I will go ahead and show you how to do this in just a moment. Okay, so what I have here at the beginning, we've got no gravitational energy, and we've got no elastic energy either, because at the beginning it's at our reference point, and there's nothing being stretched or compressed here. So the only thing that we can say it has is kinetic energy, because it's moving. So I'm going to start with 4 bars because I like 4. You could do 3, doesn't matter. Oh, I forgot to tell what was in the system. You should always start by saying what's in the system. So the system is going to have the cart or the car. We could say like the ground and the earth and other things like that, but really the car is the most important thing that's in the system. Then in the end, I said that it's not moving, and if there's no friction, then nothing's going to enter or leave the system. So we've got no kinetic in the end because it's not moving here. There's no elastic because nothing's being stretched or compressed. So all of the energy, this one's pretty easy, is just going to be in the gravitational count. Okay? Nothing goes in or out of the system here. So our qualitative energy equation is going to look like this. EK equals EG. Look at that. Pretty easy. And then we can check our math again. 4 bars in the beginning, 4 bars in the end, and that's it. There you have it. That's how you do your qualitative energy bar charts, or LOL diagrams, without any energy transfer. Thanks for listening.